So at this point, we have discussed the idea between the difference between equations and inequalities. Hopefully you recall that an equality is something that is equal to. An inequality is not necessarily equal, but it uses one of these four, where greater than or equal to, less than, and less than or equal to. So solving inequalities are basically the same exact process as solving an equation. The difference is that you have to recall that if you end up multiplying or dividing by a negative, you have to remember to flip the symbol direction. That's what we call the little red flag. So let's look at this question up here. We have x plus 5 divided by negative 2 is greater than negative 3. So what you're going to end up doing is you're going to be undoing that division of negative 2. So you're going to have to multiply by negative 2 on both sides. And because you're multiplying by a negative, you have to remember to flip the symbol's direction. So when you multiply by negative 2, you're left with x plus 5. Your direction now changes to less than. And then negative 3 times negative 2 is positive 6. Solve as normal. X is less than 1. And to place this on the number line, what you're going to do is look at your open circle. It's an open circle because it's less than, it doesn't have an or equal to. So if this is 0 and this is 1, it's an open circle on 1, and less than, everything less than 1 shades to the left. The next question. The next question says negative 8 is minus 2t is greater than or equal to negative 6. Let's go back to this one real quick. So here, just as a quick review, you will write your answer in set builder notation, the values of x such that x is less than 1. Don't forget that. Okay, sorry about that. I overlooked it. Okay, let's look at the next one. The next one says negative 8 is minus 2t is greater than or equal to negative 6. You are going to add 8 to both sides. You're going to be left with negative 2t, don't forget to rewrite the negative, is greater than or equal to negative 6 plus 8 is positive 2. You are then going to divide by a negative, and because you're dividing by a negative, you're going to flip the symbol direction. And that's going to leave you with t now is less than or equal to negative 1. Remember that if it has an or equal to symbol, it remains or equal to even if you flip it. The values of t such that t is less than or equal to negative 1. If this is 0 and this is 1 and this is negative 1, closed circle at negative 1, shaded to the left. So you notice hopefully by now that all of this is pretty straightforward. We're doing the same exact things as we've been doing with equations. So when you get to the next question, which is a little bit more complex with a distribution, you're going to know exactly what to do. So first things first, we're going to simplify this inequality by distributing 2p minus 6. Now we're going to distribute, but take the sign in front. It's negative 3 times 2p is negative 6p. Negative 3 times positive 6 is negative 18, is greater than 4p. Combine like terms. We're going to look at our 2p and our negative 6p, and that gives us negative 4p. And we're going to look at the negative 6 and negative 18, and that combines to give you negative 24, is greater than 4p. Now, you could do more than one thing here. You notice that this is on the right-hand side, and it is alone. And we have another variable with the negative 4 on the left. My recommendation is if you already have something that's on the right-hand side that's alone with the variable, bring the other one over. So what we would do is we would end up adding the 4p because we're bringing him to the right. That's going to leave you with 8p. Then you rewrite your symbol. Negative 4p and 4p cancel out. Negative 24. Now remember that this is the same thing. The way that it's written says negative 24 is greater than 8p. If it's greater than 8p, that means 8p is less than negative 24, if you wanted to rewrite it so that you can see it making a little bit more sense. Another way to look at it, you see how it's pointing to the 8, so that when you rewrite it so that the 8p is on the left, you have it pointing to it as well. Now to solve, you're going to divide by 8. You are dividing by 8, not by negative 8. And so because you're dividing by a positive, you do not flip the symbol. Don't get confused and think that because this is a negative, it flips the symbol. You only flip the symbol if you're dividing or multiplying by the negative. And in this case, you're not. So your final answer here is going to be p is less than negative 3. Set notation, all the values of p such that p is less than negative 3. And if you drew a 0 here, negative 3 would be here, 3 is here. It's an open circle, less than shades to the left. All right, let's look at the next. Okay, that was it for 2.4. That's example 2. Okay, now we get into the more intense questions. Remember, you're solving these the same manner that you would if it was a regular equation. If it helps you, you can even draw the dotted line or straight line down the inequality symbol so you know that it separates both sides. And now, remember the steps. First, you get rid of parentheses. So the first thing you do is distribute. Then you combine like terms. You rewrite what doesn't change, and you solve as normal. Distribute, combine, rewrite, and solve. Step 1, distribute. 2x plus 6, rewrite your symbol. Half of 4 is 2. X, half of 2 is plus 1. Rewrite that minus 1. So distributing is done. Now you combine like terms. The left-hand side is already simple. There's nothing that we can combine. But on the right-hand side, you rewrite the 2x, and you see that you can add this and get plus 0, which is basically the same thing as not having that 0. Now, if you recall, hopefully at this point you're remembering that with equations, you can even have things that are no solution. Well, with inequalities, it's the same exact thing. If you're looking at this here, you're going to see that 2x plus 6, is that less than or equal to 2x? Well, one way of looking at it is to ask yourself, if you knew what 2x was, you know that 2x is the same here as it is here. If you're adding 6 to 2x, there's no possible way that that's going to give you a less statement than if you just had 2x. So because that's not possible, that would be considered a false statement, which is no solution. Now imagine that you're in the middle of solving it and you're getting into it, and so you don't really think too much about it, and you think to yourself, I'm going to bring this 2x over to this side. So you're continuing to solve like normal. That would cancel out. You would get 6 is less than or equal to 0, which is also a false statement. And so because it's a false statement, the answer is no solution. So it'll be important for you to remember and recall how it is that we solve, and the fact that if you get no solution, that is also a possibility. So in this case here, if I was to write the answer here, you would just write no solution. And here there is no graph, and that's how we would say no solution. You do not graph it. It's not possible to graph because there is no solution. All right, let's look at the next one. Bring our little dotted line. make it easier. So we see fractions and we kind of get a little freaked out, but remember the same exact process that you solved equations you can do with inequalities. The only extra thing is to remember that if you multiply or divide by a negative, you flip. So just like you did with an equation, you want to get common denominators. And so if we get the common denominator of 8, that means that this here, the 1/4, is really the same thing as 2/8. So I could even rewrite that and write that that is equal to 2/8. And then I go, oh, look, every part of the inequality has an 8. See? 1, 2, 3 parts. And so these 3 parts you can actually scratch out or undivide. Remember, the whole reason that we are destroying the denominator is because every part is being divided by 8, so essentially I'm multiplying by 8 to undo it. And then you can rewrite 5 is less than 3x minus 2, and you solve like normal. Add 2 to both sides. 7 is less than 3x. Divide by 3. And you get that 7/3 is less than x, which is the same thing as saying x is greater than 7/3. Now up until this point, we have said that you leave it as an improper fraction. But because of the fact that we are graphing, you need to know where that is. So you need to change it to a mixed number so that you can see where exactly he goes on the number line. So with this, if you think about what it is that the 7/3 represents, you know that 7/3 is really 7 divided by 3, and 7 divided by 3 is 2 1/3. So x is greater than 2 1/3. Now on your calculator, it actually does this for you. And so those of you guys that have the calculator that you were asked to get, it should show you, you should be able to translate it into a mixed number. Let me show you that. Let me go ahead and open this up for you. So you can translate that into an into a mixed number. You would do 7, and then you would press the ABC button, which is right here. That makes it over 3. And you want to change it from a fraction to a mixed number. So then you press second function, and then you press the ABC button, and it gives you 2 1/3. So make sure you have these calculators, as these calculators are going to be very, very useful to you, not only for the remainder of Algebra 1, but for your SAT and PSAT and all that stuff. So let's go ahead and graph that. We know that the answer is all the values of x such that x is greater than 2 1/3. So if this is 0, and this is 1/3, 2/3, 3/3, which is 1, 1/3, 2/3, 3/3, which is 2, and then, so again, just to remind you of how this works, if this is 0, we're going to make it so that we're counting by thirds, since it's 2 1/3. So 0, 1/3 is here, 2/3, 3/3, which is 1 whole, 1 1/3, 2/3, 3/3, which is another whole, which is 2. So 2 1/3 would be right here, and it's an open circle, and it's shaded to the right. And then you can draw, for example, if this is 2 1/3, this is 2/3, this is 3/3, so right there would be 3. So make sure you do have a calculator, because your calculator is going to tremendously help you, and you need to start getting used to using your calculator for things like that, for your SATs and stuff. Okay, next one. Distribute 12y plus 48, rewrite, minus 3y is greater than 9y plus 36. And now we're going to go ahead and combine like terms. We can combine 12y minus 3y, which is 9y, rewrite, plus 48 is greater than 9y plus 36. Maybe you see the answer already. If not, you can continue. Let's say I'm going to bring this 9y over here. Both of them cancel out, and I get that 48 is greater than 36. And we know that 48 is greater than 36 is a true statement. So this is what we would call, as you all know already, hopefully, all real numbers. And the way to draw this, if you think about what it's asking you, it's asking you what are the answers that make this true, and it turns out that all answers make this true. So all real numbers means every number that's on the number line. So you would actually shade the whole number line and draw arrows to signify and symbolize that every number makes this true. So you notice that even inequalities have special cases like all reals and no solution. Okay, example 3, word problem. Ooh, we do not like word problems. We read them, we get confused. So just read it to tell yourself a story before you look for the math. The average of Jim's 2 test scores must be at least 90 to make an A. He got a 95 the first test. What does he need the second test to make an A? Okay, now we look at the math involved. Okay, we're talking about average, which is a mathematical thing. And hopefully you recall that the average of something, or the mean, is the same thing as adding up all numbers and dividing by the quantity of numbers. So that is in your head right now, based on what you need to do. We know that there's 2 tests, so that means I'm going to add test 1 plus test 2, and I'm going to divide by 2, and that's going to give me the average. It must be at least 90. Well, we remember that at least means that it has to be exactly equal or greater than. So we know that has to be greater than or equal to 90. Then it tells us that Jim got a 95 on his first test. Okay, so that means I can replace this. This test 1 is actually not an unknown. We know that it's 95. They want to know, what does the other test have to be? Well, let's erase the 2 just so it doesn't confuse us. So we know that the 95 plus the test that he takes divided by 2 has to be greater than or equal to 90. How do you solve? Order of operations. If you knew what it was, you would add and then divide. So to undo, you're going to multiply by 2 on both sides. And that's going to give you 95 plus your test score is greater than or equal to 180. And then we're going to subtract 95. And you're going to get that the test has to be greater than or equal to, and 180 minus 95 is 85. So we know that Jim must score an 85 or above on the second test to get an A in the class. So that was all the examples for this unit. Hopefully you all feel comfortable with it. Your job, your responsibility is to go ahead and complete the independent practice that is on the next couple of pages. Remember, the answers are up on Canvas for you to check, all of these, and be ready to come in and go over them in class if you have any questions. And then afterwards, you guys can go ahead and move on to the next one. But your assignments for this unit, your formatives, will include the math space F2.4, but you must complete this also, these 12 questions on the independent practice and upload to Canvas. So we're going to have a chance to work on it in class. You're expected to do these 12 questions plus the math space. So please make sure you do this. These 12 questions, I know you're going to have answers to. You're going to be able to check your work, but you must also complete the independent practice as well as the math space. Email me if you guys have any questions. I will see you tomorrow.